in this circuits problem, we have a battery of 10 volts supplying current to 3 resistors. Now, this looks like a little bit different than some of the other configurations that we've seen. Now we have a combination of resistors in series and in parallel. Okay, so let's think about how this is working. My current in the circuit, if we think about the current kind of flowing along my wires here, the current has to pass through, all of the current has to pass through resistor 1, and then that current gets split into resistors 2 and 3, and then that current has to come back together in order to complete the circuit. Okay, so resistors 2 and 3 are in parallel because the current has to split between these 2 resistors before it comes over here. So resistor 1 is in series with this combination of resistor 2 and 3, but resistor 2 and 3 themselves are in parallel with each other. So we have to find the total resistance of this circuit first. Then we can go about finding the current, total current in the circuit, and then the current and the potential across each one of our resistors in order to fill out our chart here. Resistor 1 is 30 ohms, resistor 2 is 70 ohms, resistor 3 is 100 ohms. So how do we get this total resistance here? Well, the first thing you want to do is think about the problem, and let's, we already talked a little bit about which resistors are in series and which are in parallel. So these 2 are in parallel with each other. So what we can do is we can find a resistance that I'm calling R sub 2, 3, that is the resistance of these 2 resistors in parallel. Okay, so let's do that. Let's find the equivalent resistance of these 2 resistors in parallel. 1 over R2, 3 is equal to 1 over R2 plus 1 over R3. Okay, so that's equal to 1 over 70 ohms plus 1 over 100 ohms. So that's 1 over R sub 2, 3 is equal to 1 over 70 plus 1 over 100. Take the inverse of that, and that gives me R2, 3. So R2, 3 is 41.2 ohms. 41.2 ohms. Okay. Now finding the total resistance of these 2 resistors in parallel is all that you need to do for one of your pre-lab problems. And then in the final pre-lab problem, we have to find the total current flowing through the circuit. And when we figure out the total current flowing through the circuit, we might as well go ahead and fill out our entire chart too. Now I'm going to redraw this circuit. I'm going to draw it like this. We've got our 10 volts here. I've got my first resistor R1, and now I have another resistor here that I'm going to call R2, 3. Okay, this represents the sum or the combination of these 2 resistors in parallel. Now that we've kind of put this all together, we can get the total resistance in our circuit now. Now these 2 equivalent resistors are in series with each other. So our total resistance in this circuit is going to be R1 plus R2, 3. We found the equivalent resistance of these 2 resistors in parallel, but these 2 resistors in parallel are in series with this resistor. So that's how we can redraw the circuit like this right here. Okay, so the total resistance here of this little circuit that I drew is still the total resistance of our entire circuit. And that will be R1 plus R2, 3, because our resistances add in series. And so that will be 30 ohms plus 41.2 ohms. So my total resistance of this circuit is equal to 71.2 ohms. 71.2 ohms. All right, now that we have the total resistance, we can find the total current in our circuit. I total is equal to V total over R total. So our circuit is being supplied by a 10-volt battery. So we've got 10 volts divided by 71.2 ohms, which was our total resistance. And that gives us 0.14 amperes. So this total circuit has a current running through it, a total current of 0.14 amperes. Now, let's think a little bit more about this. When we have our resistors in series, the current is the same through all of them. So that means resistor 1 also has a current of 0.14 amperes. And this equivalent resistor right here, R23, which was the combination of these two in parallel, is being supplied with also 0.14 amperes of current. For our next step, let's think about what we can get here. We know for resistor 1, we've got the resistance of that resistor, we've got the current coming through it, so we already can figure out what is the potential across R1. So let's do that. Using Ohm's law, V1 is equal to I1 times R1, so that's going to be 0.14 amperes times 30 ohms. So the potential across our first resistor there is 4.2 volts. We'll go ahead and put that here, 4.2 volts. Okay, so resistor 1, it's got a potential across it of 4.2 volts. Now we can use this other relationship here to figure out what is the potential across our two resistors in parallel. And we wrote their equivalent resistance as R sub 23. Now, R23 is in series with R1. When we're in series, the total potential of your circuit has to add together in order to give you the potential being supplied by your battery. So V total equals V1 plus V23. So if I solve this for the potential across this combination of my resistors in parallel, V23 is equal to V total minus V1. So that tells us that the potential across my resistor, equivalent resistor that we're calling R sub 23, is 10 volts minus the potential across my first resistor, which was 4.2 volts. So the potential across this equivalent resistor, which is the potential across these two in parallel, is equal to 5.8 volts. Okay, so the potential across this resistor here is 5.8 volts. Remember, this represents the total resistance of our two resistors, R2 and R3, that are in parallel. When we're in parallel, the potential across those resistors is the same. So that means that the potential across this resistor R23 is the same as the potential across R2, the same as the potential across R3. So the potentials across R2 and R3 will be 5.8 volts and 5.8 volts. Excellent. And now we can use that to figure out what is the current coming through resistor 2 and what is the current coming through resistor 3. So then we can just do Ohm's law again, but solve it for current. So the current through resistor 2 is going to equal the potential across resistor 2 divided by the resistance of resistor 2. So that's 5.8 volts divided by the resistance of resistor 2, 70 ohms, not omegas, 70 ohms. And that gives me a current of 0.083 amperes. 0.083 amperes. Now I do the same for the current through my third resistor. And that will be the potential across my third resistor divided by its resistance. And that's 5.8 volts divided by 100 ohms. And that equals 0.058 amperes. Okay, so we filled out our chart. Now we know the current and the potential across each one of our resistors here. Now, since R2 and R3 are in parallel with each other, the current, the total current coming through has to split between the two. So the total current coming through split between them, not evenly. It would only be split evenly if they both have the same resistance. So split between the two. If we add R2 and R3, that will give us 0.14 amperes back again, which is our total current in the circuit. So with those steps, we were able to dissect this circuit right here. Okay, well, what are the steps? Well, we have to find the total resistance of our whole circuit here. Then we can find the total current through our circuit. And then we can come over here, plug those into the chart that we made, and then think about what is the potential and the current across each one of these resistors or across our combination of resistors in series or parallel. We can fill in some of that information in the chart, and the remaining pieces of information that we don't know, we can always use Ohm's law in order to get at either the current or the potential across any of our resistors. And where we can, we want to use these rules right here in order to help us simplify the problem.